Hey guys, welcome back to Math Genius channel. Today's topic is matrix. Let's go to the board. A matrix is defined as a set of real or imaginary numbers or elements arranged in rows and columns to form a rectangular array. So, a matrix is defined as a set of real numbers or imaginary numbers or elements arranged in rows and columns to form a rectangular array. A matrix having m rows and n columns is called n by n matrix. You see, the m is the rows, n is the columns. So a matrix is called m by n matrix. This multiplication is pronounced as by, like this, m by n, as you can see. So this is m by n matrix. And also, the m by n is also known as the order of the matrix. A matrix is indicated by writing the numbers, the complex numbers or the elements, by writing the elements in a bracket. Example: is a matrix. This is example of a matrix. As you can see, this matrix has You know, the rows are the horizontal lines, the columns are vertical lines. So this matrix on the board has 1, 2, 3. It has 3 rows and 1, 2, 3 and 3 columns. That is to say that this is 3 by 3 matrix, 3 rows. This is the rows. 1 is a row, is a row, is a row. This is column, this is column, this is column. That is 3 rows, 3 columns. That's why we say 3 by 3 matrix. In describing a matrix, comma, the rows comes first, while the columns come second. That means we name the row before the column. For example, this is an example of a matrix, and this matrix has 1, 2, 3. How many rows? 3 rows. That is 1, 2, 3. 3 rows. 1, 2. 2 columns. So in that case, we are going to say that this is a 3 by 2 matrix. You see, we name the row before the column. The 3 stands for the 3 rows, and the 2 stands for the 2 columns. So, this 3 by 2 is the order of this matrix on the board. 2, if you have something like this, 1, 0, minus 1, 4, minus 1, 2, 3, minus 2. Look at the matrix on the board. Remember we said in describing this matrix, we describe the row first before the column. How many rows has this matrix? It has 1, 2. 2 rows. How many columns? 1, 2, 3, 4. 4 columns. So this is a 2 by 4, meaning 2 rows, 4 columns matrix. Get that? Let's look at I, a row matrix. This is a matrix that has only one row. That is, for example, of a row matrix. -1, 2, 0. Is a row matrix, and what is the order? Remember, you named the row before the column. That is 1 row and 3 columns. So this is a 1 by 3 matrix. So this is an example of a row matrix. A row matrix has only one row. Look at the column matrix. This is a matrix that has only one column. Example of it is, let's say 1, 0, 3. This is example of a column matrix. See, it has only one column, but 3 rows. So in naming it is a 3 by 1. 1, 2, 3. 3 rows, 1 column matrix. So the order is 3 by 1. This is 1 by 3. A column matrix has 1 column. A row matrix has only 1 row. Three. Let's look at single matrix. Single matrix, or you call it single element matrix. If one element is closed in a bracket, that is called a single element matrix. For example, let's say 1 in the bracket is a single element matrix. That is a 1 by 1 matrix. 1 by 1. Single element. Single element. 1 by 1 matrix. Double suffix notation. You see, every element in a matrix has a particular location or address in that matrix. And the location or the address of an element in the matrix is defined by the suffix attached, the double suffix attached to the element. For example, if we have A11, A12, A13, A21, A22, A23, A31, A32, A33, and so on. This is double suffix. So this double suffix will tell us the location, the particular location or address of each element in a matrix. If you see A22, for example, the double suffix shows the row and the column of this element. It helps us to identify the particular position or address of this element within a given matrix. That is that this particular A is found at row 2 and column 2. Where is row 2 and column 2? This is first row, this is second row, this is third row. So row 2 is on this line. Row 2. The first 2 is the row, second 2 is the column. This shows that this element in particular is in row 2 and column 2. This is row 2. I have used a straight line to show it. Where is column 2? This is column 1, this is column 2. And this column 2 now is this. That means that where this intersect is where you have found this element. So the element A suffix 22 is found here. So the double suffix helps us to identify the position, the particular location or address of each element in a given matrix. Therefore, one, 0, 2, minus 1, 4, 3, 5, 2, minus 1, 0, minus 1, 4, 2, 1, minus 3, 3. Look at this matrix on the board. You see, this particular one, this is in first row, first column. That is A11. This particular one, that means that A11 is 1, comma. This particular minus 3 is where? It's in third row. Third row. That is A3 and fourth column. 1, 2, 3, 4. Fourth column. A34 is minus 3. This has been able to explain that the double suffix helps us to identify the particular location, address of an element in a given matrix. Now let's look at matrix notation. Matrix notation. We we use a suffix ij, or we use a bold letter A to connote or denote a matrix. This ij, the I here is telling us about the rows. The j is telling us about the column. That is to say that A is a matrix. Let's say 1, 0, 2, minus 1, 3, 4, 0, 1, 2. You see, we use A to denote this matrix. We can as well use Aij if we have something like Aij to show A11, A12, maybe A21, A22, A13, A23. So these are both matrices. This is 3 by 3 matrix, 1, 2, 3. 3 rows, 1, 2, 3. 3 columns, 3 by 3 matrix. This is also 1, 2. 2 rows, 1, 2, 3. 3 columns, 2 by 3 matrix. So this is a 3 by 3 matrix. That is the order. And is a 2 by 3 matrix. So we have been able to say that in describing the matrix, you describe the row before the column. The rows, the horizontal lines, before the columns, the vertical lines in any given rectangular array. Equality of matrices. Two given matrices are said to be equal if and only if they are of the same order and the corresponding elements are the same. That is to say that if matrix A11, A12, A13, A21, A22, A23, A31, A32, A33 is equals to minus 1, 2, minus 3, 0, 1, 4, minus 2, 3, 1. If this is equal to this, first of all, look at it, they have the same order. 1, 2, 3. 3 rows, 1, 2, 3. 3 columns, 3 by 3. Same thing here, 3 by 3. Then if they are equal, it means that the corresponding elements in both matrices are equal. It means that, therefore, A11 corresponds with minus 1. A12 corresponds with 2. A13 corresponds with minus 3. A21 corresponds with 0. A22 corresponds with 1, and so on. So that is what we call equality of matrices. They are equal if the corresponding elements in both matrices are equal, are the same. And also the two matrices are of the same order. So we have come to the end of this matrix definition. The next class will be on addition. subtraction, multiplication of matrices, and so on. Thank you for staying with me to the end of this introduction. Don't forget to click on like and subscribe after you have watched the video. Thank you and God bless.
Thank you.
This particular introduction, now, I'll cut many things. See, I wanted to close this thing before. I remember that I ended the quality there. The was, so I'll cut it. But it's okay. It's well done.